A reading of the Diophantus essay. Diophantus did not consider fractions to be numbers. Although he used fractions and sometimes got them as his solutions, Diophantus explicitly excluded fractions from his definition of number. Diophantus claimed numbers are made up of some multitude of units. This description of a number is consistent throughout his works and does not have exceptions or alterations. A fraction is a part of a whole or a part of a unit, and since a part of a unit cannot be made up of units, a fraction definitely cannot be a number definitionally cannot be a number according to Diophantus. Diophantus uses the word number prolifically in his problems, yet he altered his language when introducing fractions. He says, as in the case of numbers, the corresponding fractions are called after the numbers, a third being called after 3, and a fourth after 4, so the functions named above will have reciprocals after them. Diophantus substituted the word reciprocal in a place where it would seem to have made sense to use the word number, if possible, when referring to fractions. He also changed the language in his problems. At the end of every problem in which numbers are given as part of the answer, Diophantus gave the required numbers by saying, the required numbers are, but when the solution was a fractions, Diophantus said, the required squares are. This shift in language indicates that Diophantus recognized the difference between a fraction and a number, and his language adheres to this definition of a number. Furthermore, Diophantus did not refer to fractions as numbers anywhere else in the given text. Although we do not have all of his works, the ones we do have seem to substantially alter phrasing to avoid using the word number to describe fraction. However, one confusing part of the text seems to suggest that fractions could be numbers. Diophantus defines squares as that which are formed when any number is multiplied by itself, and goes on to call fractions squares. Some fractions squares. This seems to mean that since fractions are squares, and squares are made from numbers, that fractions indeed are numbers. However, this interpretation requires an implied all before the definition of squares. All squares are formed, and Diophantus does not necessarily imply that all squares are formed in this way. He only informs the reader that this is one way to make a square. If we assume the word some at the beginning of the definition, then Diophantus would be just as consistent. In conclusion, Diophantus does not consider fractions to be numbers, because his definition of numbers excludes fractions and remains in the same by aligning his language to fit the definition.